Welcome everybody, and hope you're excited for today's session. Today we're going to be talking about accelerating GUI development, and specifically around decoupled UI and system logic, and how that leads to separate and collaborative GUI creation. So a little bit about myself and who I am. So my name's Nick Schultz. I'm a field applications engineer. I work at Crank Software. I've been with Crank for a little over 5 years now. I've worked in application development, and before joining Crank, I also worked at a company called QNX on the automotive HMI team. So I've got a pretty diverse background in creating rich interactive UIs on embedded systems and platforms. So pretty excited about this talk today and what I'm going to be able to show you. So before we get into the meat of everything, always good to kick off and show a quick agenda here. Obviously, the first thing is going to be a little bit of setting the stage before we go into a live demo. So we're going to introduce you to Storyboard, kind of what it is, why it might be different, and why you might consider using it for your UI development needs. We'll talk a little bit about the workflow in the tool when building an application with Storyboard. We'll talk a bit about architecture. So again, going back to that decoupled UI and system logic part of the title today. And then we're going to jump right into a live demo. After that, a quick wrap up, and then a chance for some live Q&A. So I'm really looking forward to getting a chance to chat to you guys later today. So Storyboard and the software we're here to talk about today. And if you've seen some of our previous chats, sort of the main introductory session on rapid GUI development, or perhaps you've engaged with us before or seen us previously at some shows in person, it's always good to give a little recap here. So, the tooling really is all about changing the way you build embedded user interfaces. We provide a platform agnostic design and runtime engine. And what that means is you have a design tool and software that runs on Mac, Windows, Linux, desktop computers. So really allowing anybody in any sort of combination of different users work on a team together to build up a UI that's really agnostic of the embedded system and software configuration. So you can start off by just focusing on what makes your UI important, and then allow the low-level system engineers to handle things like hardware selection, bringing up core system and application logic, and then how you can communicate and talk to and from the UI. So it is a very nice model. It really encourages parallel workflow and development, as well as it really brings design into the forefront. So what you'll see when we talk a little bit about the workflow is how you can engage design tools and even designers into your UI creation. So starting out with the workflow, you can start off by running with a standard tool like Photoshop or Sketch. Those are some of the big design tools on the market. And you can create a design and a layout for your UI and directly import it into Storyboard. And that's really powerful because it gives you all the building blocks you need to start adding behaviors and interactivity into the UI. You're not spending time laying out content. You're not, slicing up images or writing sort of declarative markup or XML or anything like that. You import your design and start adding behavior. There's also tools to allow you to create animations in a graphical view, and that's something we'll see in the live demo portion today. And, you can test and iterate and build up the flow all without having to write any serious code or logic. you can then, get rapid feedback. So again, the testing side of this to understand is the UI looking and feeling right. All of that is sort of separate to the hardware side of things. You can get that feedback early on in the design stage in your desktop, or even, as we'll discuss later, you could export that to a mobile phone or other configurations to test and get feedback on rapidly. The application architecture, and this is something that's another powerful part of what makes a storyboard application a little bit different than things you may have used in the past, is we really separate the UI from the core system logic. And what I spoke about earlier is, there's a design tool that allows you to create an application. And then there's also a runtime component where you will run your application as its own discrete processor task, so depending on MCU or MPU, and then you can communicate to the UI with messages and data. And that separation right there means that the UI only needs to worry about UI specific logic. It can receive events from sensors, things like, if you're building some form of a wall panel or a thermostat, you can get temperature updates from the hardware or temperature sensors in the house, and then the UI chooses how to present that. So there is a very clear separation, and then you end up coming up with a pretty clear, data and event protocol. So then you can easily make changes on either side, swapping out UIs or maybe iterating or changing architecture or structure of the back end, and each piece isn't affected. So you have a lot of power because of that, as well as, again, that parallel development really sort of stands on top of itself, where you can work before hardware is ready. You can come up with a very polished UI and then iterate on that, or perhaps develop solutions that target a good, better, best type scenario with maybe different screen sizes or features, while keeping your core backend common and consistent. So enough talk. I always like to just show it live. I think that's probably the most compelling thing. So we're going to swap out of the presentation right now and jump right into a live demo. Alrighty. So what I want to show you guys before I jump straight into the tool is I want to actually take a look at a design file in Photoshop file before we do the import. So I've got a design here. It's a thermostat wall panel sort of IoT device, and it was created by one of the graphic designers in-house at Crank here. And you can see there's a few different screens. We've got a temperature screen for a thermostat, weather, so you could imagine a external weather sensor outside, or perhaps a network source sending data in. Some setting screens for configuring language internationalization, stuff like that. Some voice settings, so perhaps you might have some voice integration. So think, Alexa, Google, Siri, something like that. And then some security. So all of those things that are pretty common in that home control type scenario. And, before we do the import, you can see there is a layout. There's some distinct screens that have been put in place. But the other thing is there's been a hierarchy described in the application. So if you look at the layout on the right here, our thermostat screen is made up of a few layers. And these are all concepts that translate into Storyboard and help you define and reuse content as you're developing. And a layer is a grouping of like content. So we have a scrolling menu that can pop out when the user clicks the menu icon in the top left. That's sort of a good candidate for a layer. Background, as you can see there, as well as things like the menu. So something that's common and going to be across all of the screens here. So, one screen will take up your display. That screen can have one or many layers. each layer will in turn then be made up of the controls and the primitives and the elements that visually represent what you see. So if you think of the menu button, and there's navigations across the bottom, there'll be text, there'll be images for the highlights, stuff like that, and that will represent an entity in your hierarchy that you can interact with, bind input events to, and trigger other behaviors. So that's pretty much it. There's also a few things you can do where you can include press and release states for buttons, so you can do kind of a bootstrapping effect on a element, so you don't have to manually hook that up. And that's all through the naming convention that you see. So that underscore layer, the underscore control defines a control element, and the glow, so you can see that up and down type effect. So whenever we see that, we parse the file, we'll wrap that up for you, and you can just hit the ground running. So all that really happens is a little bit of naming and a little bit of thought into the layout of your content, and then you're ready to hit the ground running. So I'll go ahead and I'll close this up, switch over to the storyboard view, and here we are. If you've never used Storyboard before, that's our first welcome screen. So there's links to our tutorials, documentation, our support center, the help center with the getting started guides and videos. So all really, really good resources, and we certainly suggest that you take a look and experiment with them. And we'll go ahead and close that. And then this is our main design environment, and it's cross-platform, so I'm running in a Linux desktop. You can go ahead, use it in Mac, Windows, regardless. So again, really facilitates collaborative between diverse teams and different structures and skill sets. I'm going to go ahead, import a new project from Photoshop. So there's an icon there, icon in the toolbar. Also good to note that we include a number of samples with the tool as well. So always, if you're curious about how you might implement something or an effect, check out our samples. They're great resources. So if we select that, I'm going to navigate to the PSD that you saw there. Go ahead into the Documents, PSD, Thermostat. Okay, and I'll leave everything here default. These are simply settings that allow you to configure sort of name of the project, or maybe you want to import existing or new designs into an existing project or something like that. You have options for that as well. But since I'm coming in from scratch, I'm going to leave this all as default, hit finish. And now the tool is reading the file. It's sort of parsing the names and slicing up all the images for us and laying it out as you see. And what you see here is exactly what we had in the design file. And really the only difference is we're ordering alphabetically, whereas in Photoshop you can just design your own sort of order to them. The content is all the same. If we expand each screen, you can see we've got multiple layers. There is, our menu layer, which is common and shared across all the screens, which is nice. So if I make a change to one instance, you can see that change propagating to, each instance of that layer. So again, we're very big on doing something, once and then allowing you to reuse and, benefit from that work that you've done. The other thing I mentioned, the buttons having, pre-wrapped behaviors. The plus, the minus buttons have the press, release, outbound user input events already hooked up to them. And if we select the thermostat screen, choose that as our main start screen, and simulate, you can see that we get, free press, release, drag out behavior on these buttons without doing any work. And the simulation right here, the term might actually be a little bit misleading, as this is the same core runtime engine and logic that'll be running on your embedded devices. So, the behavior, what you see here, the event routing, all the logic executes the same way on a desktop as it would on your embedded system. Obviously, the desktop has more capabilities, but at least from that early stage look, feel, design, you can do some very, very quick development and get feedback right away, and then iterate before you even have to deploy to hardware. So on that note, this is where, you can sort of see the workflow that we've got here, where we've come in directly from a design file, we're in the tool, and let's start adding some behavior. And an easy thing to look at might be the navigation along the bottom. So we've got thermostat, weather, settings. If I select our thermostat control here, I can right click, say add an action. And this is how we start hooking into the behavior and event model in Storyboard. The engine is completely event driven. And what that means is we don't do anything, we don't process, use any resources until an event kicks off a behavior. So on the left, you can see the events. And in this case, I want to look for a input event. So I'll say touch, sort of the press and release on the same control. And then I want to choose an action. The action is, that behavior that you might see. So in our case, we want to change screens, but it could also be starting a timer, triggering a script callback, sending an event, something like that. Really, an action is anything that is, a behavior. So I'll scroll down our list here and select a transition. So I'll do a fade transition, and that's you can see here there's some 3D effects that you can use if you have 3D acceleration hardware. So, sort of like the cube flip and rotates. But a fade is something that, maybe you're scaling hardware platforms. You have an MCU solution and a MPU. So this is a nice scalable type transition. Finally, I simply select the parameters I want to use. So what screen we're going to go to, in this case, the thermostat screen. I'll leave the properties here default, half a second and 30 frames per second, sort of a nice easy settings. But again, you could set these to be really anything that you wanted to. I'll hit finish. At the bottom in the actions panel, this is where you can see that, touch event triggers an action. And we can go ahead and very quickly and easily copy that, paste that template onto the weather control, and then update the destination here. So weather screen, and the same thing for the settings. And I'll choose one of the screens, security, right there. So if we save, simulate, run, now we've got that nice fading transition. All of our buttons are already hooked up for us here. Again, thanks to the import process and some naming in the design file. And we've got our full navigation sort of plumbed out. So again, I haven't really done anything complicated or special here. And this is something where, many of our customers actually find the design team should do and handle, where they'll bootstrap out the UI and then hand it off to perhaps a more technical integration team, or sort of a team or a user that does maybe some more higher level logic. So think of some script logic to receive events and do behaviors. And that's all part of the flexibility of the tool. So if you wanted to go a little bit further with this, and sort of tying this back into the topic where it's sort of separating UI and backend logic, you can look at this 20 degrees here and say, okay, well that's a great point where you would need to interface to something else. In this case, a temperature sensor or a furnace or something that's going to be sending a data update to the UI. The UI doesn't need to know anything about the backend, how it's handled, if it's remote, if it's coming over a wire, network, what have you. All it does is receives an event and then reacts to it. And the events that you saw already, if you were looking to add an event. So if I select our application node at the top here, so think of our hierarchy of the app being the roots, and then each screen and the layers without sort of being that tree structure that goes below it. You can define the context at which you bind your events to. And if I say add an action, we have our list of pre-existing events, but I can actually start to add my own custom events in. So we have our add event button, and this is where we can give a name. So I'll say something like temperature update. We can choose the type, incoming, outgoing, self if you wanted to round trip an event on the application. Give it a description and then some data. So an event with temp update, something obviously you'd want to do a little more description in a real application. And then I'll select some data. And this is where, the first time we're doing anything sort of close to software development, we're describing a bit of data and its size and how it's coming in. So for simplicity's sake, I'll select a standard signed integer value, so 32 bits. I'll give it a name and temperature. And you can choose an array count. So if you wanted to send maybe 5 values, maybe you've got an array of temperature sensors for different rooms, you could specify that as well. I'll hit finish, and you can see here now I've got my temperature. The data format here, that 4S1, simply describes the the byte count, so 4 bytes, 32 bits, the type, signed, unsigned, or float, and how many of them you're sending. So in this case, 1. I've got some helper values here for min and max field values that I can fill out, and this is going to help us simulate some data. So I'll say -50 to +50. In this case, a range in terms of Celsius, which is pretty large range, and I'll hit finish. Our new event is going to be available in the event list, and this is where I can now select an action or a behavior. And this is an event that isn't simply, okay, we're pressing a button, change a screen, or trigger an animation or anything like that. We want to manipulate and do some logic. So this is where we're going to use a Lua callback. And Lua is a scripting language that we embed into the storyboard environment that allows you to do some programmatic glue logic and data manipulation. So I'll give a name to the function callback, so cb temperature update, and hit finish. And if we look at our events, you can see everything that's hooked up in the app. Scroll all the way down there. We've got temperature update. You could also filter out some of these as well. So if you're seeing too much noise. In this case, our callback doesn't exist yet. So if I hit the edit button in the properties panel on the right, it'll pre-create this function stub or navigate to it if it exists. And I will say pre-create. We now have a callbacks file that, if we explore the project properties, lives in the script directory. Lua gives you a lot of flexibility, so you can name these files whatever you like. You can have subdirectories, you can have dependency management and requirement, all of that here. But for today, we'll keep it nice and simple, single file, single callback stub, and show you how we can hook this up. So if we go back and we remember what we actually did in our event, and there's a way you can see your user-defined events here. We created an event with temperature update, and we provided a data value associated called temperature. So when we receive that callback at the application level, so regardless of what screen we're on, we're going to receive the event. We're going to execute this callback, and then the properties of that event are going to be passed through this parameter here called mapargs. And that contains all the context information that you might need. So in this case, things like, we handle our nice handy autocomplete there, the name of the event, the control you're doing this on, the context. So perhaps if you think of a touch event, you could get the name of the control that triggered it. So a generic handler for a button, maybe. You could also get things like the X and the Y coordinate values, timestamps, things like that. So I'm going to print out, just for sanity's sake, the event name, and then also the event data that we're passing along there. So again, the context event data, and this is where, if I remember correctly, we specified temperature. We got that print statement now. We can go ahead, simulate that. We'll run it, and I'll pin this to the top. And if we go to the right here, we have this connector view. And this connector is allowing us to simulate a backend. So, if you think of that kind of open-ended or closed loop type testing, we're doing all of this without real software backend. So in this case, I have my slider here. And if you remember, I set some values when we define the event. And if I drag down, you can see the event name, temperature update, and the value being printed out in the console. And we've got a range from -50 to +50. And this is very powerful because, we can do all of this without relying on backend software. We don't need hardware to be ready. We don't need sensors, none of that. So you can come up with an event protocol that is, sort of a standard form of communication to the UI and backend subsystems or middleware or other services. So with this, we can now take it and we can apply it into our UI. So we can start doing some live updates and data manipulation, which is pretty awesome. So go ahead and close this. In our callback, so we can pull out the data. So describe a local variable there, call it temp, and I'll just copy this. So we're going to grab that, and we need to push it back into the UI. So far, we haven't really shown how you do that binding. And, we've talked about the storyboard application hierarchy, but, another key feature of Storyboard is the fact that we can set what's called a variable on control properties. And if I look at this temperature or text field right here, it's a control, it has a text property, and right now it's static text. But we can go and assign a binding to a variable, and this variable could be at the control level, it could be something at global or screen level, if you will. And then if you update that variable, any reference to it will automatically update on the fly. So all of these properties, you may have noticed, have this angle bracket plus icon sort of icon there. And that means you can put that variable binding or, a dynamic hook into your property. And this really is, the key to doing anything in Storyboard. It's a pretty simple construct, but that's how you set up your data bindings and how you, put live data and effects into your user interface. So if I select that icon, we have a variable selection screen where you could select a pre-existing one or create your own. And in this case, I like the idea of sharing temperature across the UI because maybe it's referenced on multiple screens. So it makes sense to, create it up at a global level. And you can see we already have some font variables described there for us. And during the design import, the tool recognized some common fonts and already bound it up for us. So if ever we wanted to change our light font or medium or condensed down the line, we just need to change that font value and any font referencing it will automatically update. So again, very, very, very nice. Great for reskinning and theming, things like that. So create a new variable. I'll call it temperature and hit finish. And you can see there our variable is there and we've now bound to it. And that binding is, the qualified path of the variable. So if at the app level, it's simply the name. But if you created it on a control, a layer, or a screen, you would then describe, screen.layer. control, or what have you. So again, pretty simple. But we can also go ahead and bind that to the weather temperature here. So just for example, that multiple elements referencing a single variable. Select that, scroll up to the top, and create that binding. So now if I make an update, perhaps 22 degrees, you can see that variable updates both of those screens. And back in our script callback, the same thing can be applied. So within the context of the Lua script callback, we can go ahead and set that data value. Inside Lua, there's a series of functions stuck behind the GRE namespace, and anything that I've done in the model, you can do as well, more or less in Lua script. I haven't really showed you creating animations or timers or anything like that yet, but there's also APIs for doing that. So you can see animation create, cloning, deleting controls, preloading resources, things like that. So again, fully spec'd out API for handling any of the glue logic you might need to do. But in this case, all I really need to do is set a value, which is a nice simple call where set value takes a key and value pair. The key being the variable, so temperature. And if you're ever not sure as well, you can sort of look at the variable definitions in the variable panel, and you could even copy the path. So if you have some that are set on a control a few layers down, you could copy path, paste them right in. But that looks good. Put that in there to be safe. And the value here is our new temperature value. So temp. And what I do want to do is, you can see down here, I've got this degree symbol. So for presentation purposes, I'll actually go ahead and concatenate that value there. Oops, didn't copy that. And Lua is a dynamic interpreted language, so you can do the type conversion inline here, and comment out the print statement. But in 2 lines of script code, you can actually receive a value from an external source and present that to the UI. So if we go back, run our application, jump back to our connector tab, start dragging our slider, and you can see we've got live data updating in our design. If we switch over to the weather screen, we have that same binding in place, and that's how we start creating live behavior. And that flow where we bind an event to an action applies to triggering an animation. So if you were to build an animation with our animation record feature or programmatically in Lua script, you could then receive an event, trigger your animation, and then also key off of events on maybe the animation completes and do something else. Or if an animation finishes, then maybe transition screens and send an event to the back end to say, okay, I need to show this data now, or something like that. So again, you're fully able to combine those features in any way that makes sense to your application. But again, the important part here is, we've done all of this in isolation of any hardware or software development. The communication protocol that we are using to send events and data is actually the same library that we'll provide for sending events to the running application. So that library is called Storyboard.io. It's a C library, so you can include it in your C applications to send and receive events, similar to message queue API. And we have some samples that show you how you can go about setting that communication up. So Cluster.io or Thermostat.io are a great example for you to look at. They also have some sample C programs that you can compile. There's a Makefile, Visual Studio project, depending on what system you're running, and great reference for starting to hook up to live systems and real data. But that's all part of sort of that next step of integration and connecting with other things. But to do that, we need to prepare the application for export. And we've done some work, and this is where maybe we want to test it on real hardware, or export it for a stakeholder to see. And to do that, we need to come up with a export configuration. And this is where, depending on what you're targeting, whether it be an MCU or an MPU, because we're offering that agnostic scalable solution, you can start defining that. So in this case, you can see here, I've got an export configuration. It's targeting what I would say is a higher level embedded system. So something like embedded Linux, WinCE, QNX, something like that. So probably an MPU, there's memory protection, features, things like that. But, we can start defining the resources that we're including. So if you wanted to, include all of your scripts and your images, things like that, you can set those there, fonts, say, okay. You can start choosing other properties. So in this case, this will be our default configuration, but maybe you want to also create a configuration for an MCU. Go ahead and do that. And in the case of the MCU, you may not have a file system, right? You're probably running everything out of Flash. So you can go then configure your configuration, this virtual file system, and you'll see the estimates on the right starting to update as we go. So giving you a rough estimate for RAM or flash storage. And then you can say, okay, I want to export my images, raw, uncompressed, so we don't have to decompress them into RAM and draw them directly out of Flash. And again, you're going to see the updates there. So, a lot of configuration you can do, and this is all going to be specific to your end target platform, whatever you choose. But when you're happy with that, you have your export configurations. You can then go and export your application. In the case of, wrong one there. In the case of your, embedded Linux, QNX, WinCE system, you can select a packager here. It's called the GAP package. This will export a version of the model file you have there in a .gapp format. That's something the engine will interpret and run on the system. And, again, you can select your configuration right there and choose where you're doing it. If you have one of our demo images, then that's where you can actually go through, set up an SCP transfer. So if you're booting one of the images running Linux or something like that, put in the IP address, the username, password, an output directory. All of this information is contained in our Help Center. Deploy it and execute the launch script, so you can actually run and execute that application live on hardware. Maybe you don't have hardware ready just yet. So instead of a GAP export, you might be looking at an Android export. So if you wanted to deploy this onto a mobile phone or tablet for people to test with, you can use this packager as well. There's also on Windows systems a standalone exe export. So you could generate an exe, maybe to send to management or another stakeholder to run. Or in the case of an MCU, you could select your embedded resource header, where you can export everything into an embeddable header file to link into your project, whether it be something like FreeRTOS or MQX, or even maybe your bare metal sort of OS type shim. You can do that, export it, and then build it into your project. So that is sort of the the workflow, the round tripping, how you create an application that's decoupled from back-end development, and you can iterate and prototype and move to production in that model. One last thing that's also pretty cool, if you're looking to go one step further, is after you've exported your application and maybe you've SCP'd it to your embedded system, you can then configure your system to listen on a particular network port. So the Storyboard.io library has the feature that if you want to include it, you can listen over the network for a TCP socket connection. And then the simulator options here allow you to specify a remote channel, something, TCP. You could put in an IP address, 192.168.0.1, and then a port, 55555. And then, once you're up and running over there, you could reflect these events, over the network. So again, that one step further, simulating your application on real hardware with, data that may not be coming from a sensor, but from all intents and purposes of the application is coming through the standard communication channels in the standard format. So hopefully you found this interesting and insightful. I'm going to go ahead and jump back to the slides to wrap everything up here. And then we'll get on to live Q&A. All right, so hopefully you guys enjoyed that demo, saw something new and useful, and sort of got you guys thinking about how you might be able to incorporate this into new designs and projects or workflows. Always a good thing to check out if you're curious or you're in the process of doing an evaluation right now, our Help Center. So support@cranksoftware.com. Another great contact link as well. And there's knowledge base, getting started videos, documentation, API references, all of that available there. So check out the Help Center. As well as, it's always great to connect with us. So, really what we want to do is we want to hear from you. We want to learn about what you're doing and how we can help you. So again, the Help Center is a great resource, but getting in contact with someone like myself or people in our support center are a great way to open a dialogue. And again, we really want to encourage evaluation. So we've got a free trial on our website that you can download, free unlock 30-day trial. Software is not limited in any way to play around with that, as well as some demo images. So those demo images are pre-built for a lot of the common evaluation boards available on the market right now. So you can take one of them, download it, copy it to an SD card, boot your board, and start deploying live and testing on hardware as well, which is another really, really powerful feature. So thank you guys for your time today. Really, really enjoyed doing that. And we're going to go ahead and open things up for some live Q&A.